Jai Hind everyone, myself Dr. Vandana Sharma from Ajay Kumar Garg Engineering College. My subject is Engineering Physics, code is KS101T, and the topic which I am discussing, that topic is Relativistic Mechanics. So I have already mentioned in my previous lectures that in relativistic mechanics nothing is absolute. All the physical quantities, all the physical parameters, they will be affected because of the motion of object. And relativistic mechanics, basically it is applicable for those moving objects when the speed of an object is comparable to c. But we have also seen that this relativistic mechanics is equally applicable when the speed of a moving object is very small with respect to c. It means you can describe the motion of any moving object with the help of relativistic mechanics. We have derived 4 equations which are known as Lorentz transformation equations in order to correlate the coordinates of one inertial frame with the coordinates of other inertial frame. So what we have done, we have derived 4 transformation equations which are known as Lorentz equations. So what are those Lorentz equations? I hope you remember that x dash is equal to x minus vt upon root 1 minus v square upon c square. This is your Lorentz transformation equation for position coordinate, and in this particular case the direction of motion is along x axis. So this is your first equation, and the second coordinate y dash is y, z dash is z, and the time transformation is t dash is t minus vx upon c square upon root 1 minus v square upon c square. These 4 equations, this particular set, this is known as Lorentz transformation equation. So these equations are applicable when you have 2 inertial frames, one is s and other one is s dash, where s is at rest whereas s dash is moving, and it is moving with a constant uniform velocity v, which is comparable to c. So when v is comparable to c, in that case you are getting these 4 equations. Means you can write x dash in terms of x, you can write y dash in terms of y, z dash in terms of z, and t dash in terms of t. These are your Lorentz equations, and we have derived these equations with the help of special theory of relativity. So using that, using those 2 famous postulates of Albert Einstein's special theory of relativity, one is principle of equivalence and one is principle of constancy of speed of light. Using those postulates, you will derive these 4 equations, and these 4 equations, actually these equations, they are the heart of relativistic mechanics. Means you can derive any relationship or relationship for any physical parameter in relativistic mechanics using these 4 equations. So these equations are very important. After this, what we have done, we have tried to prove that whenever an object is moving, and if it is moving with a relativistic speed means v is comparable to c. So whenever you have a moving object and that object is moving with a relativistic speed, then along the direction of motion in relativistic mechanics, the length will be contracted, and that will get contract through a factor of root 1 minus v square upon c square. It means if L naught, that is the original length or length of the object when object is at rest, then for a stationary observer, the length of that object along direction of motion is L naught into root 1 minus v square upon c square. So L is always less than L naught if v is comparable to c. So that is a very important aspect of relativistic mechanics, that length is affected by motion. Then in my previous topic, I have discussed about time dilation. So what we have discovered there, we have discovered that time is also affected by motion. Means if you have 2 clocks, if you are having 2 frame of references, s and s dash, and one is stationary and other one is moving, then according to the concept of time dilation, the stationary clock, that will always measure a longer time interval as compared to a moving clock for an event which is occurring in moving frame. So according to the concept of time dilation, you have this particular concept. T is T naught upon under root 1 minus V square upon C square. So we are getting this formula according to the concept of time dilation. So this particular time T naught, it is the proper time, and this T time, this is known as dilated time. And you can see here, whenever V is comparable to C, then T is greater than T naught. Means the stationary clock, this time interval is measured by the stationary clock. This is always greater as compared to T naught if V is comparable to C. So that is the concept of time dilation. After that, we have discussed that time dilation is a real effect. So in that, what we have done, we have taken the example of mu mesones. So we have proved there that if we have mu mesones, so these particles, these mu mesones, actually they are created in our atmosphere approximately at a distance of 10 kilometers from the surface of Earth. Means if this is surface of Earth, then above 10 kilometers from here you are getting these mu mesones. So actually they are created at a distance of approximately 10 kilometers from the surface of Earth. And these mu mesones, they are highly unstable particles. Why they are unstable? Because they can exist, they can remain in their state only for 2 microseconds, and after that they will convert into electron and positrons. Means their identity will remain only for 2 microseconds. And these mu mesones, they are also traveling with a very high speed, which is approximately 0.998 c. So if you have mu mesones and if they have this lifetime, and in this lifetime with this speed, you can calculate how much distance they can travel. So if you will calculate it, then the distance traveled by these mu mesones in their average lifetime is only 600 meters. But these mu mesones, they are also present at the surface of Earth. Now the question arises that in this small lifetime with this much speed, how they can travel a distance of 10 kilometers. So what I have told you that this presence of mu mesones at the surface of Earth, that is actually because of time dilation. So since these mu mesones, they are traveling with this relativistic speed, so this concept of time dilation, that is applicable for these particles. So T, that will be equal to T naught upon under root 1 minus V square upon C square. It means instead of 2 microseconds, the lifetime is 2 microsecond upon under root 1 minus V square upon C square. So if you will calculate this lifetime, then it is approximately 3.15 into 10 raised to power minus 5 second. Now in this dilated time, with this much speed, you can travel the distance traveled by these particles. So if you will calculate it, then that distance traveled is approximately 10 kilometers. So actually the presence of these mu mesones at the surface of Earth, that is a justification of this time dilation, or in other words, you can say that time dilation is a real effect. So this topic was our last topic which we have discussed in our, this topic was our topic of last lecture. Now today we are going to start this topic, which is again related to the concept of time dilation or time transformation. The concept is principle of simultaneity. This is principle of simultaneity. So first I would like to explain the meaning of this principle of simultaneity. So principle of simultaneity means if you have two events which are simultaneous in two initial frames, you have two events which are simultaneous. Suppose there are two initial frames, one is S and the other one is S dash. Now if you have two events simultaneous in S frame at two different positions, means in frame S, if the two events, they are occurring at x1 and x2 position, suppose the first event that is happening at position x1 and the second event that is occurring at position x2 in frame S, and these 2 points, they are different points, means x1 is not equal to x2, but the events which are occurring at these 2 points, those events are simultaneous. So if in frame S these events are simultaneous, then you can say T1 is equal to T2. So this is the case, you have two events which are simultaneous. Simultaneous means they are occurring at same time. So if these two events are simultaneous at two different positions, since I am saying different positions, so x1 is not equal to x2, then according to principle of simultaneity, these two events are not simultaneous in other inertial frame. They are simultaneous in S frame, but these events, they will not be simultaneous in S dash frame. You have to prove this. This is principle of simultaneity. So what is your principle of simultaneity? Mathematically I can say, according to principle of simultaneity, if we have two inertial frames S and S dash, now suppose in frame S two events are simultaneous. Simultaneous means T1 is T2 and let that is equal to T0, and these events, they are simultaneous at two different positions, and let the first event that is happening at x1 and the second one at x2, and x1 is not equal to x2. So now you have to prove that these events are not simultaneous in this second inertial frame. So suppose this second inertial frame that is moving with this relativistic speed with respect to first inertial frame, and let this frame is at rest. So this one is at rest and this particular frame is moving with respect to S. So if it is moving with constant uniform velocity, then both the frames are inertial. So you have to prove that if the first event for S dash, if that is happening at T1 dash time and the second one at T2 dash time, then these two events are not simultaneous for S dash frame. I hope the question or the statement is clear. For this frame, these two events are simultaneous, but they are simultaneous at two different positions. Now you have to prove that these events are not simultaneous in second frame or S dash frame. So in order to prove this, you have to use time transformation equations. So what are time transformation equations? According to time transformation equations, you can write the value of T1 dash. What will be that? If T1 is known and you know the position at which the event is happening in frame S, that is x1. So your T1 dash will be T1 minus Vx1 upon c square upon root 1 minus V square upon c square. This is the value of T1 dash in terms of T1. And the value of T2 dash in terms of T2, what will be that? It is T2 minus Vx. Now the point at which this event is happening in frame S, that is your x2. So you have to take x2 here, Vx2 upon c square upon root 1 minus V square upon c square. So you have T1 dash in terms of T1 and x1. You have T2 dash in terms of T2 and x2. And how you are writing those equations? You are writing these equations using time transformation. Using Lorentz equations, you are writing these equations. So you can find T1 dash minus T2 dash using 3 and 4. This is your 3, this one is 4. You can see here the LCM of these two terms, that will be root 1 minus V square upon c square, and when you will solve it or simplify it, you will get here T1 minus T2, and the second factor will be V upon c square and your x2 minus x1, right? So you are reaching at this stage, and you know T1 and T2 both are same because the events are simultaneous in frame S, and according to equation number 1, both are equal. So if both are equal, so this particular term will give you 0. So finally what you have? You have here T1 dash minus T2 dash is equal to V upon c square into x2 minus x1 upon root 1 minus V square upon c square. Now we have a very important point here. As you can see in this term, in this equation, denominator, that is root 1 minus V square upon c square, that is constant, and its value depends upon the relationship between V and C. Second, this V upon c square, that is again a constant. So the relationship between T1 dash and T2 dash, that depends upon the relationship of x1 and x2. And you know what is the relationship between x1 and x2? Both are different. It means this t1 dash minus t2 dash, that can be 0, and that will be 0 only if x1 is equal to x2, because there is no other condition under which you can get this t1 dash minus t2 dash 0. Since this factor, this x2 is not equal to x1, this entire term is not equal to 0. So if this term is not equal to 0, then t1 dash minus t2 dash is not 0. It implies that t1 dash is not equal to t2 dash. It means the events are not simultaneous in S dash frame. So this is your principle of simultaneity. So I have proved here. Now I am showing you the slide in which the derivation of this principle of simultaneity is done. Process is same. So this is your principle of simultaneity. So what you have here, this you have simultaneous event, two events are simultaneous at two different positions, one at x1 and the other one at x2, and both the events are simultaneous, so you are writing t1 is equal to t2. I have already discussed all these things. And according to time transformation, what will be t2 dash? It will be t2 minus vx2 upon c square upon this, and t1 dash similarly that is equal to this. So if you will find the value of t2 dash minus t1 dash, or you can find t1 dash minus t2 dash, both are same thing. So if you will simplify this, you are getting here v upon c square x1 minus x2 upon this, which is not equal to 0. It means t2 dash minus t1 dash is not equal to 0. So both are different. t2 dash is not equal to t1 dash. So events are not simultaneous in another frame. So if two events are simultaneous in one inertial frame, then those events need not to be simultaneous in other inertial frame. This is our principle of simultaneity. I hope this is clear. Now we will solve a few numericals based upon the concept of length contraction and time dilation, right? So I am taking my first question based upon length contraction. So the question is, you have two inertial frames, one is S and another one is S dash, right? Now S is at rest and S dash, it is moving with constant uniform velocity v, which is comparable to c. So both S and S dash are inertial frames. Clear? Now you have a circle in frame S, and you have to prove that that circle will appear as an ellipse when it is observed from another inertial frame. I hope you are getting my question. You have to prove that x square plus y square is equal to a square, which is the equation of a circle that will become as an ellipse when it is observed from another inertial frame, which is moving with a constant relativistic speed v, which is comparable to c. So you have to prove this. So you know what is this? This is the equation of a circle, right? So x square plus y square is equal to a square. That is your circle. Now you know, according to the concept of length contraction, when you have an object which is moving, then the length of that moving object, that will get contracted, and it will get contracted through a factor of root 1 minus v square upon c square. It means this x can be written as, according to the concept of length contraction, suppose your S dash frame, S is at rest, this is S, and S dash, let it is moving along positive direction of x-axis. So if the movement is along x-axis, then in that case the contraction will take place only along x-axis. That y dimension will remain same, because we have already learned in through that concept of length contraction that the contraction will take place only along direction of motion and other dimensions will remain same. So since there is movement only along x-axis, so this x can be written as x dash, if x dash is the position in S dash frame, so x dash into root 1 minus v square upon c square. This is according to the concept of length contraction. And since there is no movement along y axis, so y will be equal to y dash. So you have this equation number 2 and 3. Now substitute these values in equation number 1. So what you will get here? You will get here x dash into root 1 minus v square upon c square whole square plus, instead of y you will write here y dash square equal to a square. So if you will simplify it, you will get here x dash square upon 1 upon 1 minus v square upon c square. I hope this is clear how I am writing this, plus y dash square is equal to a square, and if you will divide by a square throughout this equation, then you will get x dash square a square upon 1 minus v square upon c square plus y dash square is upon a square is equal to 1. Now you can see here this term in the denominator, this particular term is constant. This a, that is constant, v is constant, c is constant, and I am replacing this entire term with v square. Just for simplifying it, I am writing it as v square. So finally what you are getting? You are getting this x dash square upon v square plus y dash square upon a square is equal to 1. So tell me, what is this? You know, this is the equation of an ellipse, and you can see here x dash and y dash, these are the coordinates in s dash frame. It means this is the equation of ellipse with respect to frame s dash. So a circle, when it is moving with a relativistic speed, then for a stationary observer it will appear as an ellipse. Why it will appear as an ellipse? Because along the direction of motion there will be a contraction, and that contraction will take place by this factor, this particular factor, root 1 minus v square upon c square. So I hope this particular concept is clear to you now. Now moving ahead. Now next question, I am taking a question based upon time dilation here. So you have a clock, and that clock is keeping correct time. So what you have in this question, there is a clock and that clock keeps correct time. Now you have to tell me that with what speed that clock should move so that it may appear to lose 4 minutes in 24 hours. What I am saying, you have a clock and that clock keeps correct time. Now with what speed? You have to find the speed with which that clock should move so that it may appear to lose 4 minutes in 24 hours. 4 minutes in 24 hours. So you know that whenever an object is traveling with a relativistic speed, then time is also affected by motion. So since you have a clock which is keeping correct time, and you have to find out the speed with which that clock should move so that it may appear to lose 4 minutes in 24 hours. So that difference of time that is possible, that change in time by that particular clock is possible when it is traveling with a relativistic speed. So we have to find that particular speed, and you know, according to the concept of time dilation, what is the formula for time dilation? T is equal to T naught upon under root 1 minus v square upon c square, and you know this T is always greater than T naught, right? So since the clock is keeping correct time, so T, you have to find that particular speed with which it should travel so that it may appear to lose 4 minutes in 24 hours. So T is your 24 hours. 24 hours means you can convert it into minutes as well as seconds. So I am converting it into minutes, 24 into 60 minutes. So this one is 1440 minutes. So your T is 1440 minutes, and T naught. So this T naught, that is the time measured by the moving clock, and that moving clock will measure a time which is short by 4 minutes. It means the time 1440 minus 4. So 1436. This is the time measured by that moving clock. So now you have the value of t, you have the value of t naught. Now just what you have to do, you have to simplify this equation for this particular speed. So you can simplify it. You have root 1 minus v square upon c square, which is equal to t naught upon t, and this will be 1 minus v square upon c square equal to t naught square upon t square, and further v is equal to c into root 1 minus t naught upon t. And you know what is the value of t naught, you know what is the value of t. So this is c into root 1 minus this t naught is your 1436 and this is 1440, both are in minutes. So just simplify it and substitute the value of c, you will get the required speed, and that speed will be the speed with which the clock, if the clock will move, then it will lose 4 minutes in 24 hours. So I hope this is clear that how to solve the questions based upon time dilation, right? So this question is based upon time dilation. So you have to choose the value of t and t naught here, because the clock is keeping correct time and when it is at rest, so this t is the stationary clock. So 24 hours is the time. So 24 into 60, so 1440 minutes, and t naught, that is the time when the clock is moving. So there is a difference of 4 minutes, loss of 4 minutes. So t naught is 1436 minutes. So just simplify using this formula, you will get the value of relativistic speed of that particular clock. I hope this is clear. Now I am going to solve one more question based upon this time dilation. So you have to practice all these numericals based upon length contraction as well as time dilation. So next question I am taking here. Suppose you have mu mesons or pi mesons, these elementary particles you have, and let the lifetime of these mu mesons is 2 microseconds. So the lifetime is 2 into 10 raised to power minus 6 seconds, right? And these particles, they are traveling with 0.998 c. Clear? Now you have to calculate that what will be the time traveled by these particles without relativistic effect. Means how much distance these particles can travel if you are not considering any relativistic effect. So you have to find the distance traveled. So distance traveled without any relativistic effect. This is the first part. So you have to calculate this distance traveled without any relativistic effect. So that is simple. You have lifetime of those particles and you also know what is the speed of those particles. So what will be the distance traveled? Distance traveled will be equal to v into t naught. So you know what is the speed? It is 0.998 into c. C means 3 into 10 raised to power 8 meter per second, and that lifetime is 2 into 10 raised to power minus 6. You have to just simplify it. You will find the distance traveled without relativistic effect. Clear? Now next part of this question is, you have to find the distance traveled with relativistic effect. The first part was without relativistic effect and the second one is with relativistic effect. So you know that with relativistic effect means when you are considering the relativistic effect, then the time is not 2 microseconds, that will become longer, and it will become longer by this factor t naught upon root 1 minus v square upon c square. So what you have to do, you have to find that time first. So it will be t naught, which is 2 into 2 10 raised to power minus 6 upon under root 1 minus 0.998 c square upon c square, that will get cancelled. You have to simplify it, you will get the lifetime of these particles with the relativistic effect, and then you will calculate the distance traveled in this particular time, which is v into t. So now you can first you can solve it for t, and after finding t you can find the value of d. So this is with the relativistic effect and the first part is without relativistic effect. So you have to solve the numericals based upon length contraction as well as time dilation. In the next topic, we will derive relativistic velocity addition theorem. Means if you have two inertial frames S and S dash, and if a particle is there which is traveling, which is in motion with respect to both the frames, then how you are going to correlate the speed of that particle in one particular frame with the speed of particle in another frame. So that we will do with the help of relativistic addition theorem. So that is our topic of discussion for next lecture. So we will discuss this addition of velocities or relativistic velocity addition theorem in our next lecture. So for today, that's it. Thank you so much.